So this is Jeff Hamrick at Rhodes College again, and I'm going to talk about building scatterplots in SPSS as well as computing correlation coefficients. So to build a scatterplot in SPSS, you first have to have some data, bivariate data that's scalar. I've already imported the breakfast cereal data that we've been working on in class recently. It has in it pre-computed these quantities, sugar per cup and calories per cup. And remember that we're going to view calories per cup as being a function of sugars per cup, i.e. Sugars per cup will be the independent variable and calories per cup will be the dependent variable. To build a scatterplot, I go up to Graphs and select Chart Builder, and then I choose in the gallery the scatter/dot plot, and I'm going to drag this option from the upper left-hand corner into the main area of the wizard. The variable I'll move into position on the x-axis is sugars per cup, and the variable I'll move into the y-axis is calories per cup. And so this is a stylized version of the scatter plot that we're going to see in a minute. I press OK so that we can create the scatter plot in SPSS. It's labeled both the x and y axes for us. To add a least squares fit line to this chart, what I'm going to do is double left click on this chart, and I go to Elements and I ask to fit a line at total. So if I do so, the default is to fit a best least squares linear fit to the data, and that's the line right there. Here's the r squared associated with that line. We'll talk more about that a little bit later. I just press close to get out of this option, and here we have a scatter plot with a least squares line in SPSS. To compute the correlation between sugar concentration per cup and calories per cup, I'm going to close this out and close out the output without saving it. We go to Analyze and then Correlate. We want to do a bivariate analysis rather than, for example, a partial correlation, which is not a concept we'll learn about in this class. So I choose this option, and I just add the variables that I'd like to study the bivariate correlation between, namely sugars per cup and calories per cup. There are, as we've mentioned already, many different versions of correlation coefficient. The Pearson correlation coefficient is the primary one we're interested in Math 111. The Kendall's tau coefficient and Spearman's coefficient we may work with a little bit later this semester. As part of computing a correlation coefficient in SPSS, you can automatically run a test for significance with either a two-tailed alternative hypothesis or a one-tailed alternative hypothesis. The null hypothesis is, of course, h0 rho equals 0. So I'll go on ahead and use, since I have to choose one or the other, the two-tailed alternative. You press OK. SPSS thinks for a minute, and what you actually have here is a correlation matrix. The correlation between sugars per cup and sugars per cup is 1. The correlation between calories per cup and calories per cup is 1 as well. That's not surprising. The Pearson correlation between calories per cup and sugars per cup, though, is 0.536. The double star here indicates that it's a significant correlation. The p-value associated with it is 0 to 3 decimal places. Note that, of course, the correlation between sugars per cup and calories per cup and sugars per cup is the same. It's 0.536. That's because correlation is a symmetric concept. So this is how you build scatter plots and compute correlation coefficients in SPSS.